From CPRE and the CPRE Knowledge Hub, this is Research Minutes, a weekly look at new and important research in education. Today, we look at results from an 11-year study of students in college, which found that smartphone usage may be having an increasingly negative impact on both knowledge retention and performance on exams.
To my surprise, 2011 students were no longer doing better than they were in 2010. It was the same. And then 2012, 2013, 2014, 2015, in fact, performance is getting worse and worse and worse.
We welcome Rutgers University psychology professor and study lead author Arnold Glass. Glass discusses what he learned about the relationship between homework, smartphones, and test performance.
After all that practice, they were less likely to know the answer than the very first time when they were presented with a question.
And some important implications for education policy, practice, and future research.
The way our brains work, the cost is just too far down the road to see, which is tremendously unfortunate, which is why I'm trying to get the word out about this.
That's right now on Research Minutes. Hello and welcome to Research Minutes. I'm Keith Heumiller, Managing Editor of the CPRE Knowledge Hub. Today we're speaking with Arnold Glass, Professor in the Department of Psychology at Rutgers University. Thanks so much for joining us, Arnold.
Thank you for having me.
So today we're discussing your new study, which was co-authored with Rutgers University's Meng-Shui Kang, titled Fewer Students Are Benefiting from Doing Their Homework, an 11-year study. It was just published in the journal Educational Psychology, and it provides some insight into a couple of different areas that, at least until recently, have been relatively understudied, including the potential impact of cell phone usage on student performance. To start, though, I'm curious what drew you to this line of research all those years ago? What kinds of questions did you have, or possibly what kinds of student behavior did you observe that led you to this study?
This was a long time in coming. Really far back when I first became an assistant professor in the last century, it seemed to me if there was anyone in the university who had this ethical obligation to do a good job of teaching, it was someone who was allegedly studied learning and memory and therefore should know the optimal ways to create instructional methodologies to help their students do well. However, for a long time, it became clear that the technology didn't exist to actually translate what we knew about learning and memory in the laboratory into actual classroom instructional methodologies. So for many years, I was frustrated and dreamed about that technology arriving. And in this century, it did in fact arrive in the form of course platforms and personal response systems that now allowed me to do things that were impossible to do previously and to actually apply, to test whether the effects we got on learning and memory in the laboratory would, in fact, as I thought they would, greatly improve exam performance in real classrooms with real students. And so my actual classes became not just for the purpose of instruction, but I was able to collect an enormous amount of data that allowed me to pretty much know what a student knew at any point in the semester and when they learned something and when they forgot something, because throughout the semester I was asking them multiple versions of the same question. I had all these questions which really had the same answer, and I could track whether they got each version right or wrong. And this both allowed me to fit models of learning theory to see which one fit the improvement in performance as I varied various factors, but also gave me way more information than anyone had ever collected before on how students learn in an actual class. Now, I applied all this to perfect an instructional methodology called distributed questioning. What was well known in the laboratory is something called the question effect, which was that if you give someone something to study and they can just study it as long as they want, the amount of time doesn't matter, versus you just have them read it or hear it once and then you ask them a question about it, they remember the material better and much longer if you ask them a question. Right? Questioning generates actually a part of the brain which produces long-term retention. So you want to mix up exposition with lots of questions in order to generate long-term retention for what you think it's important for the students to know. So there's a certain amount of engineering that goes into transferring a laboratory effect into the classroom. But I was very satisfied to see, as I got control of the technique in the classroom, every year students were doing better and better. As I went from 2005, 2006, 2007, 2008, 2009, 2010, exam performance was getting significantly better. I was finally reaching the point where 50% of the students were doing 90 or better on the final exam, and I was really getting close to my fantasy that 90% of the students would all get A's if they just did what I told them to. But then, to my surprise, beginning and for the first time, 2011, students were no longer doing better than they were in 2010. It was the same. And then 2012, 2013, 2014, 2015, in fact, performance is getting worse and worse and worse. So that was a shock and a disappointment. And clearly something else was happening that I hadn't counted for, that was counteracting the effect of what I was doing in the classroom. And it turned out that there were two things going on. One thing, which is the result of an earlier paper. Before 2010, when you taught a class in college, basically students had two options. They could pay attention to you or they could sleep. And some actually did sleep. But for most of them, I mean, they were paying attention to you, and that led to reasonably good retention, since they're smart kids, of what you were saying. But after 2010, when you taught a class, actually, they clearly weren't paying attention to you. They were all looking on their smart devices, doing social interaction or watching a video or playing a game or something, and they would occasionally look up at you to just kind of follow along what you were saying. And so what I did in the earlier study is for half the classes, they were allowed to do what they wanted, and the other half of the classes, I had a proctor, and the only thing they could do was just pay attention to me. And sure enough, when you looked at exam performance, students did anywhere from a half to a whole letter grade better on material when they were forced to actually pay attention to me and couldn't divide attention in the classroom. So that explained part of the decline in the performance, but didn't explain the entire decline in the performance. Because students have homework assignments before every single class through the semester, so I had all this data from their online homework performance. And one of the obvious things is if you give people several study opportunities on materials, so they study, test, study, test, study, test, study, test, every time you have another study test interval, the probability of getting the answer correct goes up, right? Makes sense, but that's in fact what you find. When I looked at just the entire class data for the whole class, it looked like I was getting that obvious result that you always got. But when I looked at it more carefully and used a sorting algorithm, I found that there was a subset of students who showed a completely different pattern. For them, they did very well, 90 to 100% correct, on the online assignments, but they did much worse on the classroom assignments where there are quizzes in classes or the exam. So they weren't showing an incremental improvement. In fact, they got a truly remarkable result in that I had all these versions of the same question. The probability they got that question correct the very first time they saw it, before I even lectured on it as a pre-lesson question, they got it right about 90% of the time. But 4 weeks later, after they had gotten that question at a minimum a second and a third time on the exam, they only got that question right about 80 to 85% of the time. So literally, after all that practice, they were less likely to know the answer than the very first time when they were presented with a question. So I interrogate students, of course, to find out what they're doing, and I fit it to the data. And it became clear that what happens now is students can get much better scores on their homework than they ever did because they're tremendously skilled at searching the internet for answers. Right? So they have a homework assignment, they have their smartphone, they have Google and other facilities, and amazingly rapidly, they can find the right answers and put them all down and then feel very good about themselves because they're doing very well on their homework, better than students did before. But even though they'll remember, of course, what they looked up and what they answered that day, and maybe even the next day, a week later, they're probably not going to remember the answers and they probably won't even remember the questions. And that's because since they didn't first generate the answers for themselves, they never activated the part of the brain which is involved in long-term retention. Their entire experience was a short-term retention experience, and that's why it will all fade away. Therefore, when the actual exam comes up, all that homework that they got those high scores on, that's useless because they don't remember anything of that experience. So they have to start studying all the material over from the beginning, which is a truly, truly terrible outcome for students who actually think they're doing well and have been led to think they're doing well by their intuitions and by the feedback they're getting from high grades. So I was really appalled to discover this. And I was also appalled to discover that, and this is not surprising, that over the 11 years of this study, that the percentage of students who were now showing this phenomena of doing better the very first time they got the question on the exam, so their exam performance was lower, had gone from 15% to 50%. Okay, and it was really in danger of becoming so ubiquitous that you couldn't even study this anymore because all students would be showing this bad behavior. And so I thought it was really important to alert the world in general, but students in particular, to what was going on so they could make an informed decision about how they could study given the catastrophic consequences of what was happening to some students right in my own class right now.
Could you give us a little bit of an overview on how you actually studied this? I understand that most of your work or all of your work took place among college students there at Rutgers.
Yes, it did take place among college students. I teach a large lecture class, appropriately enough, on cognition, and I have two sections of the course in a large lecture hall back to back, so I have hundreds of students. But the advantage of having two sections is I can do experimental designs, which means these are within subject, within item designs. So if there's some manipulation I want to test to see how it affects student performance, I can have each of the students experience the manipulation half the time over the course of the semester, the 28 class periods and the 3 exam periods. And I can split the items into 2 groups. So half the students have one manipulation with one set of items, and the other half of the students have the other manipulation with the same set of items. And so when I have a within subject, within item design, I really have the gold standard of experimental design. So at the end, I can be very confident of these results.
So let's jump right into your findings then, beginning with the relationship between homework answers and future test performance. Could you walk us through what you learned there?
In my study, students will get one version of a question during the day or two before the class in which I'm going to go over material. They get the second version of the question in class. They'll get a third version a week later as a review question. And then they'll finally get a fourth version of the question on the exam. What should happen, since let's face it, you have to give the same answer over and over again, is every single time the probability of you getting the correct answer should go up, up, up. And so it should peak on the unit exam. And in fact, it should be even higher on the final exam at the end of the semester when you get a fifth version of the question. And it used to be that was true for all the students. But as I've said, now the number of students who are showing that pattern is declining. And it's declining because the earlier attempts to answer the question, regardless of whether or not the student comes up with the correct answer, if they don't remember the answer to the question, either the answer or the question the next time I present another version of the question, then it doesn't help them. And that's why I'm not seeing any improvement in performance. I can show this is true because, as I do on occasion, I can force the students to pay attention. Like when I had a proctor going around in class and making sure they were paying attention to me, or I can force them online by having them read a little paragraph and then answer for that particular paragraph. And when I force them to pay attention, then, of course, it does have an effect on the exam. But absent my forcing them to do that, I'm getting this other pattern. And I can understand why, because after all, they're getting the correct answer. And no one has any insight that if you remember something today and you think you can remember it tomorrow, that you're going to forget it a week from now. I mean, our memories just don't work that way. And so they get sucked into what for them is a very efficient strategy for doing very well, using a tool that they're very familiar with and it's become second nature, like a habit. I mean, this is such, habit. I mean, all day long, when you want to know something, you go to your phone and you look it right up, and that's no problem. Because 99% of the time when you're using your phone to get information, you don't want to remember that permanently. I mean, that's what you got the cell phone for. The one time where this is a bad idea is in class, where the whole point is you're trying to learn to remember something. And that's the one time when using the cell phone to just get that information quickly is detrimental rather than a positive. And so I don't blame the students for misapprehending this whole thing. There are all these rewards and no obvious cost to what they're doing, but that's just because they can't see the cost. The way our brains work, the cost is just too far down the road to see, which is tremendously unfortunate, which is why I'm trying to get the word out about this.
Speaking of getting the word out, it seems that your work here is already starting to have an impact, particularly your findings about how phones have likely changed student behavior over time. So I guess I just wanted to ask you, what do you think the implications of your work are? What are the big takeaways here?
I wish I could be sure it was having an impact. I'm not confident that it is. They're just strong cultural presuppositions. So people, when they look at the findings, they say, oh, well, that's interesting. But it isn't like there's anyone else on the planet who feels that they have an obligation to tell anyone about these results, trying to get the word out. But it's going to take, I can see, considerable more effort before more than a significant number of people are going to be aware of these findings, because apparently other people don't feel that this is as compelling as you and I feel that these are compelling findings. And that's unfortunate, because once you understand what's going on, the answer is not to throw away the technology, but there are fixes, which if I could take the time to systematically study, which should easily solve the problem. What you have to do is you have to convince students, and it's better to set up the technology so they have no choice, that they get a question, they have to generate an answer on their own, even if it's a guess. And only after they've generated their own answer, even if it's a guess, do they go ahead and use their smartphone to find the answer, the correct answer 1, 2, 3. Everything we know suggests that if they always first generate and commit themselves to an answer, which they may have to change if it's wrong, then in fact they will have long-term retention of the entire experience. So what they're doing will ultimately improve their exam performance. So I would like to systematically do this and demonstrate that it works and then get the word out on all this. But there's just not enough interest in the world. People have funny ideas. They internalize whether they're smart or dumb, which is always a bad thing to do. And today, people are more reticent than they were in the past of telling other people how they should study or learn. And so everyone kind of washes their hands of the whole thing, which is, from my point of view, very unfortunate.
I did just want to follow up on the replicability or the applicability of your results here in the K-12 sphere. I know that the work you did was in higher ed, but do you think that there are implications here for K-12, for younger grades?
You get the kind of findings I'm working with people of all ages in the laboratory. If you do training rather than instruction, you can get these results with animals. So I'm sure that it will generalize to K through 12. In fact, I have some data that indicates it might, but the problem is I can never get funding for the K through 12, so I don't have enough data ever to publish. But I'm sure if I could, that I'd get exactly the same results. I mean, there's not really that much difference at that point in human beings and what they're doing. These are fundamental effects.
So then that brings me to my final question for today, opportunities for future research. Do you think that this is an area of study that should continue either for you or for others who are working in this field?
Well, obviously, since I've devoted such a big chunk of my life to this, I absolutely think that this is extremely important. Here in this century, we have all these wonderful new technologies. However, there's this very superficial view of how to handle them, which is basically, here's this great new technology, use it, and of course, you and the world will be better. But that's just crazy. These things are very powerful tools with very powerful consequences. Just because we are intending them to use them in a good way doesn't mean that we will be able to foresee every possible effect they're going to have. There may be some negative effects for some people, others for other people. And therefore, from the very beginning, I've always attempted to systematically look at the effects of using new technologies so that we could use the tools that are now available to us to our best possible advantage. If I wasn't committed to doing that, I would have never discovered the phenomena that we're talking about today. But that whole approach that you should actually figure out what the tool is good for, how to use it, seems completely alien to the land of hype that we live in today. There's no interest or support anywhere for investigating what are the best ways to use the new technologies or to systematically look at the positive or negative effects that they might have.
Well, Arnold, this is incredibly intriguing work, and we want to encourage our listeners to go and read the full article. Again, it's titled, Fewer Students Are Benefiting from Doing Their Homework, an 11-Year Study, and it was just published in the journal Educational Psychology. Arnold Glass, thanks so much for joining us today.
Thank you so much for having me. I'll appreciate this forever.
Thanks for listening to this week's Research Minutes, presented by the CPRE Knowledge Hub. For more episodes or to subscribe to the series, you can find us at researchminutes.org. To share thoughts on today's episode or to suggest a future topic, you can find us on Twitter at CPRE Hub. That's CPRE Hub.